In this video, we're going to look at an amortization schedule for a 2-year bond bought at a premium, bought at a price higher than the redemption value. We're going to split it into two parts. One part that's going to focus on doing a lot of calculations with the calculator. We'll be constructing the amortization schedule and calculating totals. And a second part where we look at generating formulas based on the patterns that we see in the table. That'll be a more abstract part. Mostly we've been doing exercises from the 6th edition of the Mathematics of Investment and Credit by Samuel Broverman, as well as The Theory of Interest by Stephen Kellison. However, in both of these books, I couldn't really find exercises that do quite exactly what I'm going to show you here, so I made up my own problem. They have examples in the reading similar to what I'm going to show you, but no exercises. So here's the problem description, and down here you can see the table already pre-made to a certain extent to save some time. Made this up here. We've got a $1,000 2-year 12% bond, redeemable at par, the face value $1,000, with semi-annual coupons. This is the coupon rate. As an annual rate, 6% would be the semi-annual rate. It's bought at a premium to yield an 8% return convertible semi-annually. It's bought at a price higher than the redemption amount. That will happen whenever the coupon rate is higher than the yield rate. So again, the first part of the video, we'll be constructing the table, the amortization schedule, to show the amortization of the premium. The fact that the premium is, again, we are paying higher than the redemption value. We want to see how the outstanding balance or book value goes down over time. And the outstanding balances just after the coupons are paid at the end of each half year. Also in part 1 of this video, we'll find totals for the columns for the interest earned, the payments, and the principal repaid. And finally, in the second part of the video, we'll construct general formulas from the patterns that we see in this table. We'll mostly think about this in the context of the premium discount formula, and that is probably the best way to think of this typically. The premium discount formula for the price of a bond in general is typically written as the price is the coupon or the redemption value, typically called C, plus the coupon amounts, F times R, face value times semi-annual coupon rate, minus C times J, the redemption value times the semi-annual yield rate, times A and J, your present value of an annuity immediate with end payments based on the yield rate, semi-annual yield rate J. In the case where C equals F, you can of course also replace the C's by F's and factor an F out of this one to write it this way. And in this case, this quantity right here represents the premium if it's positive, if R is bigger than J, which it is in this example, or the discount as a negative number if R happens to be less than J. So this is the formula we will use to find the initial outstanding balance. That will go right here at time 0. Our times are in half years here. So let's use the calculator. So for the initial outstanding balance, let's go ahead and write it out first. F is C is 1,000. So we have 1,000 plus 1,000 times R minus J. R would be half of this, 6% or 0.06. J would be half of this, which would be 4% or 0.04. There's 4 coupon payments, and J is again 0.04. So this is 1,000 plus 0.02 times 1,000 is going to be 20 times this. Let's go ahead and use the calculator now. 1.04 is 1 plus J. Take its reciprocal to get V. Raise that to the 4th power. Subtract from 1. Divide by 0.04. A4 is about 3.629895. Multiply that times 20. Add 1,000. The price of the bond at time 0 is $1,072.60 if you round it. I'm going to keep all these decimal places, and in the table I'm going to keep all the decimal places, though of course in real life things would get rounded to the nearest cent. But I'm going to keep all those decimal places. So that's going to be the outstanding balance at time 0, $1,072.597904, which again would round to $1,072.60. But again, let's keep it like this. Now, before I continue on, I want you to realize, conceptually speaking, in filling out this amortization schedule, it's very helpful for you to think of a bond as a loan. What do I mean by that? Well, you imagine yourself purchasing a bond from either a corporation or a government entity. You are, in a sense, loaning them money. You have become the bank to them. You are giving them money at time 0. That's the price. That's a loan. In this case, the loan is $1,072.60. They are paying you back with interest over time. The coupon payments are part of the interest, and the redemption value at the end you could sort of think of as possibly being part of the interest, but also completely paying off the balance, whatever the balance happens to be. Now, when you buy the bond at a premium, the coupon rates are going to be such that your payments, or the I should say the corporation or government entities' payments to you, are going to be higher than the interest that they owe. So that is going to reduce. There's going to be a principal repaid portion that's going to reduce the outstanding balance or book value until at the end you get down to $1,000 before the $1,000 final redemption amount gets paid off to bring the balance down to 0. Okay, let's see how that plays out here. So how do you calculate the amount of interest that they owe you at time 1? It is just as if you are owing some interest and maybe doing just pure interest payments on a loan, although again, the actual payments they're going to pay you because you bought this at a premium is going to be higher than the interest that they owe. So you take the balance, $1,072.597904, and multiply times the semi-annual interest rate, which comes from the yield rate, half of this, 4%. So I got to take 4% of this. That'll be what they owe you in interest at the end of the first half year, times 0.04, times 0.04, there we go. They owe you $42.90 of interest at time 1. And like before, let's go ahead and use more decimal places. I don't think I'll use all of them, but let's use 6 places after the decimal. Okay, that's the interest that they owe. How much did they pay you at that time? They pay you more than that. They pay you based on the coupon rate of 6%. They pay 1,000 times 6% per half year, I should say. They pay you 60 at time 1. Okay, so the balance goes down. By how much? Take 60 minus the interest that they owe. That'll be the principal repaid at time 1. Subtract this from 60. $17.10. 17 point, let's carry 6 decimal places, 0.096084. 17.096084 is how much the principal or outstanding balance or book value gets reduced. So now subtract this from the 1,072. And again, I'll carry all the decimal places. The book value is now down to $1,055.50. Carry those decimal places and we continue. The interest they're going to owe at the end of the second half year is going to be 4% of that amount. It's going to be a little bit less. Take 4% of this times 0.04. 42.22 is what goes here. If I carry more decimal places, I get that. They're still paying the coupon of 60. So the principal repaid at time 2 is going to be this minus that. Subtract this from 60. It's going to be a little higher, principal reduction. 17.779927. Subtract that from the 1,055 now. We're down to 1,037.72. Carry more decimal places and get this. Probably some error has crept in already, at least at the last decimal place or two now, but you know, this should be right to the nearest cent. That's why I'm carrying more decimal places. Continue, times 0.04, 41.508876, right there. They pay 60. Subtract this from 60. The principal repaid at time 3 is 18.491124. Subtract it from this now. Get 1,019.23. Take 4% of that. We're almost done. Get 47.769231. They pay 60 plus 1,000 really as well. Let me put that in a different color here to pay off the final balance. The principal reduction that comes from just the $60 is $19.23. Notice this is $19.23 above 1,000 right there. We also make the final balloon payment, pay off the loan, so to speak, with the final payment of 1,000. The $19.23 brings this balance now around to the nearest cent to 1,000 exactly, but then we paid the 1,000 off, and we get a final balance of 0 after we do that. Okay, so it's not too bad to see this. Again, you could think of you as being the bank, and you are loaning money to the corporation or government entity, and this is just keeping track of their balance of what they owe you. They are paying more than the interest that they owe each half year. Let's go ahead and calculate the totals of these things. And then I will stop this part of the video and come back and do the general formulas. So here we're just using the calculator. I'll go as quick as I can. 42.903916. I'm at the interest column here. Plus 42.220073 plus 41.508876 plus 40.769231. That's round to the nearest cent. The total here is $167.40. The payments total to, with the coupon payments, they total to $240. Then we have the final redemption amount of 1,000, giving you $1,240. How much do the principal repaids add up to? The green ones should add up to, if you think about it, to $72.60. Let's double check that they do. That's the amortization of the premium. 17.096084 plus 17.779927 plus 18.491124 plus 19.230769 adds up to $72.60, just like I said. $72.60, and then we add on 1,000 to bring the balance down to 0. And that concludes the first part of this video. All right, we're on to the second part of the video about the amortization schedule for a 2-year bond bought at a premium, where we're going to take this amortization schedule that we see here and think about it in terms of general formulas and try to confirm that the general formulas do give us what we see here. It might be helpful before I embark on doing this to realize that in this example, F times R, the $1,000 times 6% is the coupon amount is 60. F times J, it turns out, it could be helpful to think about as well. That's 1,000 times the yield rate, as a semi-annual yield rate of 4% is 40. F times R minus J is 20. And F times R minus J times A for J, N is 4 here, and I will be using N equals 4 here to keep things simpler, is the amount of the premium. It's this excess above $1,000, $72.60. I will carry all those decimals, 72.59597904. Those just might be helpful to remember as we go through what we do here. So as far as the outstanding balance or book value, OBt or BVt at time zero, right when you buy the bond, it's the same as what I got from the premium discount formula. Let me just go ahead and rewrite it symbolically right here. The face value, which is the same as the redemption amount because it's redeemable at par, plus the premium, which is F times R minus J times A and J, where N is 4. I will keep the letters F, R, and J without their special values for the most part here, but I will plug in N equals 4. That is the outstanding balance at time zero, or the book value at time zero. You can think of book values as something you want to keep track of if you're doing accounting. As we go on, it's not necessarily the same as what you could resell the bond for, because bond rates, bond yields change based on market conditions, and so the book value doesn't necessarily match that, but it's still convenient for the purposes of accounting. All right, so we already confirmed that that's what we got when we use the formula here, is 1,072.597904. What interest do we get, do they owe here at the end of half year one? They owed $42.90, which was 4% of this amount. We took the semi-annual yield rate, 8% divided by 2, 4%, or 0.04, and multiplied it by this. That was J. Let me go ahead and just write symbolically here, J times this whole thing, F plus F times R minus J times A for J. As a symbolic way, we could represent that interest. Let's go ahead and simplify it a little bit, but I'm out of room up here, so I will simplify it down here. I'm going to simplify it by multiplying the J through. J times F is just F times J. When I multiply the J times the second term here, however, it cancels because, remember, well, let's use a red pen here. A 4J is really 1 minus B sub j to the 4th over j. So the j here is going to cancel with the j there when I multiply. And what I'll be left with then will be f times r minus j times 1 minus vj to the 4th. Like that. Okay? Let's leave it like that for the moment. We could try multiplying this out, but let's leave it like this for the moment. What is the payment? The government or the corporation is paying you more than the interest that they owe you based on buying the bond at a premium. You are loaning them more than you're going to get at the end. At the end, you're kind of going to get a loss in a sense. They need to pay down their outstanding balance down to the redemption amount here at time 4. The payment is just the coupon. It's 60, which is F times R. Let's now figure out a formula for the principal repaid. Remember that we found this number by taking 60 minus that number, so let's do that symbolically now. What's going to go here? Let's think about it down here to leave ourselves some room. I need to do this minus this, which I will think of as this minus this, and I will now expand this out here. So I have F times R, the coupon amount, minus this. And let's go ahead and multiply all this out. So I've got a FOIL. R times 1 is R times F is plus FR. That's first times first. Outside times outside is R times negative Vj to the 4th. Also multiply times F. I get minus FR Vj to the 4th. Inside times inside here is negative J times 1. So I get a minus Fj. And last times last is negative J times negative Vj to the 4th. Plus, don't forget the F, plus Fj Vj to the 4th. And some things cancel. Let's see, a little bit cancels here at least. The FR here cancels with the FR there because of the minus sign distributing through. This F times J cancels with that F times J. And what we're left with is this and this with the minus sign distributed through. So let's see, there's a common factor of f and vj to the fourth that can be factored out. I distribute the minus sign through, that minus and that minus make a plus r, and this plus and that minus make a minus j. Hey, we've seen that before. That is, let's see, well, I guess I have not written that down before. Okay, anyway, let's just go ahead and put that back up here. I was thinking of this thing here. It's related to that, but not equal to it. F times r minus j times vj to the fourth is what we get there. Let's use the calculator to confirm that that is correct in this situation. F times r minus j is 20. What's vj to the fourth? 1.04 is 1 plus j. Its reciprocal is v. Raise that to the fourth. I get this times f times r minus j, which is times 20. And I get that number, 17.09608382. I'll continue. You might ask what the benefit of all this is. The benefit is that you could encounter a problem where maybe you want to know the principal repaid after 3 payments have been made, and you want to therefore know the general formula for what would go here instead of trying to make the entire table. That's the benefit of thinking about and knowing these formulas. All right, what goes here? Now I could completely work by analogy and just essentially do the premium discount formula again, except this time with n equal to 3. But let's see if we get the same thing by taking the original book value minus the principal repaid. Let's see if that gives the same thing. Let's use blue here. So I want to take the original outstanding balance that came from the premium discount formula, and I want to subtract the principal repaid like this. And actually, if you think about this carefully, you can see this does reduce to the same thing as this, except with n equal to 3, without even doing any expansion. If you don't want to, this thing is the present value of an annuity immediate with payments of 1. It's going to be, as a summation, v plus v squared plus v cubed plus v to the fourth. It's being multiplied by this just as this v to the fourth is, and this one's being subtracted. Those terms involving v to the fourth are going to cancel. The terms that involve v to the first, v to the second, v to the third don't cancel. If you want, you could emphasize that by saying this is vj plus vj squared plus vj cubed plus vj to the fourth. But yeah, f times r minus j times vj to the fourth is going to cancel with this minus f times r minus j times vj to the fourth. So what we will be left with is f plus f times r minus j times a3j. Just as you would expect if you use the premium discount formula, sort of rethinking about the bond here at time 1. We may want to confirm with the calculator that this is giving us the right thing. Let's do that. So A3, let's see, 1.04, reciprocal, there's V. Raise it to the third power now. Subtract from 1, divide by 0.04. Oops. Let me redo that. 1.04 reciprocal to the fourth, excuse me, 1.04 reciprocal to the third. Subtract from 1, divide by 0.04. A3 is about 2.674 times, this thing was 20, plus, oh, that's not coming out right. Something must be wrong here. Let me redo it one more time. 1.04 reciprocal to the third. Subtract from 1. Divide by 0.04 times 20. There we go. That's better. Add 1,000. 1,055.50182. Okay, it's off by 1 decimal place there at the 6th place after the decimal. Not a big deal. All right, that formula is working. We continue that. We look at these patterns. We continue them down. This would evidently be j times f plus f times r minus j times a3j. which could be simplified to something similar to what you see here, except with a third power there instead of a fourth power. This is still f times r. Follow the pattern here. You'd be subtracting this, so there'd be no fourth power to subtract. It would simplify for the principal repaid to f times r minus j times vj cubed. Let's double check that that works. 1.04 reciprocal, there's v to the third power times 20, 17.779927, just like we have here. This would be f plus f times r minus j, a2j, etc. What might be worth confirming now are a couple totals. Let's see, if we add up these principal repaid things here, which I don't even have to do the adding because I'm going to see a pattern here. Add up those things, you're going to get f times r minus j times vj plus vj squared plus vj cubed plus vj to the fourth. And that is the same as a4j. The sum of those is 7260 when you round it to the nearest cent, which is the same as the premium of 1,000 for the original price, $72.60. That makes sense, okay? And you can see the formula for the premium. This part of it right there is the same as what we have down here. How about the sum of the interest payments? Maybe best thought of in this way. If I add those up, I've got 4 of them. I'd have 4 times fj. I would also have, let's see, I'd have f times r minus j. I'd get 1 plus 1 plus 1 plus 1 is 4. And I get a minus, ultimately, vj plus vj squared plus vj cubed plus vj to the fourth. Let's see, I'm not sure it's best to keep it that way. Let's see, if we multiply this out, what's going to happen? I'm going to have a 4fr. I will also have a, maybe I should have kept this as an a4 here. I will also have a minus 4fj. That will cancel with this one. I will also have a plus or a minus fra4j coming from this times f. And it looks like the last thing that I have is a minus or a plus, actually, fj times this a4j. Might want to double check my algebra there. So this can be rewritten as 4fr. Looking at these two terms here, I can factor out an f and an a4 and be left with j minus r, which is going to be a negative quantity here. Let's go ahead and use the calculator now to confirm that this gives us 167.40. This thing is going to be negative. Let's figure that out first. A4, 1.04, reciprocal to the fourth power, subtract from 1, divide by 0.04, times 1,000, times negative 0.02. I'll just type it in as a 0.02. This is negative 72.60 when I round to the nearest cent. 4 times f times r is the sum of all the coupons, 240. 60 times 4. This is 240. So to finish the video off, if I take 240 minus that, subtract this from 240, I should get the total interest paid, 167.40, which is what I have here. Okay, so that's a lot to take in, I know, in a short amount of time. You probably want to re-watch this video and rethink about everything. Try to think about it on your own. That'll be really beneficial. I will maybe in the next video or another video soon, I will do an amortization schedule for a 2-year bond bought at a discount instead of a premium.